And then we describe the third quantum number, which is the orbital. So you have an energy level subdivided into sublevels, and each sublevel is subdivided into what are called orbitals. And it makes a lot of sense if we start back at the pictures again. When we're dealing with sublevels, we know here that the first energy level only has one sublevel, that would be 1s. Therefore, it only has one orbital, and it looks like a sphere. Energy level 2 has two sublevels possible, the 2s and the 2p. But notice it's a little different. The s, the 2s, has one orbital again. It's only got the one shape possible. But the 2p orbitals have three options here. We have the x orientation, the y orientation, and the z orientation going in and out of the board. You don't have to call them px, py, and pz, but you can see that there are three different orientations for those sublevels. These are called the orbitals. S has one orbital, p has three. Here you can see that the d sublevel has how many orbitals? 5 different orientations, each representing an orbital where electrons can exist. And that would start in the third energy level, because you'd need 3 sublevels, the 3s, the 3p, and the 3d. And then lastly, here's the f sublevel, and you notice that it can only exist at the 4th energy level and beyond, because you'd need 4s, 4p, 4d, and then 4f. Notice how many options you have geometrically here. 7. 1, 2, 3, 4, 5, 6, 7. And the electrons can exist in one of these 7 orbitals. So again, mathematically, if we look at this, the third quantum number corresponds to the orbital, or the orientation in space. And we give it the letter m as a designation. And mathematically, n can be plus to 0 to minus, and it's related to L actually. Okay, and then, again, we're not going to stress this stuff. You know, N is for the energy level, L is for the sublevel, and then M is for the orbitals. Bottom line, what you can see here is mathematically the first energy level has only one option, 0. That's one orbital, the s orbital. N equals 2, okay, can have the m value of plus 1, 0, and minus 1, meaning that there can be 3 orbitals, and that's the p sublevel. And you keep going. Notice the next one has 5 options here. D can have 5 orbitals, and F can have up to 7 if you count those up. But I think the pictures are worth 1,000 words here. You can see clearly that's 7 orbitals, that's 5 orbitals, there's 3 orbitals, and then the S only has 1. Now when we're dealing with the third quantum number, or the orbitals, we can use n squared, that's the energy level, to indicate the number of orbitals in a particular sublevel. For instance, energy level 1 has s for a sublevel. If you do n squared, that means 1 times 1 is only 1. That means the first energy level can only have 1 orbital and 1 sublevel. Energy level 2 can have n squared amount of orbitals, can have 4 orbitals. That makes sense. You have the 2s, that's one of them, and you have 3 p orbitals. Again, the x, y, and z range, and you can see them over here. Energy level 3, n squared would be 9 different orbitals. You can have the 3s, that's 1. You can have 3 3p's, that's 3 more, that's 4 total. And d can have 5 orbitals. If you add those up, that would be 9. And then lastly, energy level 4 can have up to 16 orbitals, which would be 4s is 1. There's 3 in the 4p sublevel. There's 5 in the 4d sublevel. And there's 7 in the 4f sublevel, meaning that you can have up to 16. And we're not going to stress how many orbitals are on each energy level. We're going to stress the 4 quantum numbers: energy level, sublevel, and now orbital. Within each orbital, you can have up to 2 electrons. So let's just look down through here. Quantum numbers are based on energy. We already said that. Energy is equal to Planck's constant times the frequency. This thing called degenerate electrons is where electrons exist in the same sublevel, have the same amount of energy. It's like being on the same flight of stairs. That step has the same energy. Equals 1 can have one sublevel and one orbital, which can contain 2 electrons. Energy level 2 can have 2 sublevels, S and P. S has 1 orbital, P has up to 3 orbitals, and each one of these can have 2 electrons. So this can have 8 electrons. Energy level 3 can be subdivided into 3 sublevels. The S sublevel has 1 orbital, P has 3 orbitals, and the 3D sublevel has 5 orbitals. Each of them can have 2 electrons. So if you add that up, 2, 4, 6, 8, 10, 12, 14, 16, 18 electrons total in this energy level. That doesn't exclude these. You include them all. And then the 4th energy level, again, can have 4 sublevels. S has 1 orbital, P has up to 3, D has up to 5, and F has up to 7. Each one can have 2 electrons, so that's 32 just in this energy level, and then you add all those with it. Now, when we began this unit, we talked about energy being like a staircase, where there's no ramp, it's not gradual increases in energy, it's step-by-step increase. So let's see how that works using the first 3 quantum numbers. If we say that n equals 1, okay, we know that that means it's referring to the first row of the periodic table, hydrogen and helium atoms. And being energy level 1 means it can have 1 sublevel, which would be S. We would call it 1s. There's the first quantum number, there's the second quantum number. Then we also need to know how many orbitals it would have. And we know that S, by definition, has 1 orbital. And we can use a line like this to designate that, or we can use a circle like we did before. Let's compare that to energy level 2. Okay, if we change it now to energy level 2, it's going to go a little higher here. Energy level 2 can have 2 sublevels. And those would be the S and P. You go from lowest to highest, S, P, D, F, so S and P. So now it would be 2S. There's quantum number 1, quantum number 2, 2S. Then there are electrons available that will exist in an orbital. Okay, but that's not all. There are 2 sublevels, and that would be 2p. And we said that p can have up to 3 orbitals, so you actually have to draw it like this. Okay, see how it's kind of a staircase, and there's nothing in between here. There's no gradual ramp. It's going to pop right up. Okay, what we will do is we'll put the electrons in there, kind of like this. This is actually the 4th quantum number, and I'll cheat a little bit, show you that. It would look like this eventually, and let's just draw. This is what nitrogen would look like. And this is what's meant by degenerative electrons. They exist on the same plateau, the same basic energy, and electrons will repel each other. So that should help with the 3rd quantum number.